Beginning at 100, David counts down by 11 at a time. What is the first number less than 0 that David will count? Counting backwards from 100, we'd go 100, then 89, and then so on, right? I mean, you guys can do that. And then eventually you go down to 12, and then 1, and then it would be minus 10, and this is the first number less than 0. What is the value of 1 plus 2 all the way to 20? Well, the formula, some of you know, 1 all the way up until n, consecutive digits, is n times n plus 1 over 2. It's a nice formula. So therefore that would be 20 times 21 over 2, and that is 210. In the diagram, a triangle ABC is right angled at B. AB is 24, BC is 10. If AB and BC are each increased by 6, how much does AC increase? Okay, the first thing, do I have to figure out? Yeah, I do. Okay, so AC squared initially with this diagram is 24 squared plus 10 squared using Pythagoras, right? You guys all know that. So when you do this math, AC becomes 26. So in this diagram, it would be 26. Now what they're saying is that you're going to increase each of these by 6. So this goes to 30 and this goes to 16. And then what is AC? Okay, well, if that's the case, then the Pythagorean relationship this time is 30 squared plus 16 squared. And this time when you solve for AC, it is 34. So that 36 would actually go to 84. And that is a increase of 8. In the diagram, ABCD is a trapezoid with BC parallel to AD and AB is equal to CD. Point E is on AD so that BE is perpendicular to AD, and F is on point of intersection of AC with BE. If AF is equal to FB, angle AFE is 50. What is the measure of angle ADC? So let's do some angle chasing here. The first thing I want to do actually is drop a perpendicular down like that. And let's see what we can get. First of all, what am I trying to figure out? ADC. So where's ADC? ADC. This angle right here. Okay. So by symmetry, that would be the same as this angle. So let's see what we get. Okay, 50 is AFE. So AFE is this guy right in here, and that's 90. So then that would be 90 minus 50. So that's 40, right? Yeah, 40. And then this angle would be 180 minus 50, so that's 130. And then since this is isosceles, these two guys, that guy and that guy, will be the same, but they would total 180 minus 130, which is 50. So each of them would be 25, 25, and 25. So that means this whole angle right there is this 25 plus that 40, which is 65, and that's what this would be, because it's symmetrical based on what information they gave us. In the diagram below, how many rectangles contain both circles? How many rectangles contain both circles? Okay, so let me break it up. A 4x4 rectangle, square, same thing. A 3x3, 2x3, a 2x4, and a 3x4. Okay, so let's see what I can do here. 4x4 is the big one, the whole one. So there's only one of those. So let's just keep a count here. 3x3. 3x3. There's this one. And then there's this one. So there's two of those guys. Now, unfortunately, I kind of not necessarily messed up the diagram, but I have to use a different color for 2x3. 2x3, I think there might only be one. Just this guy. Yeah, that's it. And then 2x4, let's see here. 2x4, I think just this one. And then 3x4, that one, I'm pretty sure that one has a few, actually. Let me see. A 3x4. A 3x4. Oh boy. So this one, that one, this one, and then this one right here. Yeah. Okay, so 3 of those guys. Okay, so I'm pretty sure that is the tally. So what's this? 1, 2, 3, 4, 5, 6, 7, 8. So 8 rectangles contain both circles. What is the smallest positive integer that is a multiple of each of 2, 4, 6, 8, 10, 12, 14, 16, 18, 20? All right, so we're basically being asked for the LCM. And instead of those numbers, I'm going to write them in prime factorization, because that's pretty much the process of figuring out LCM. So let me just put them all in there. And then once I do, I will talk to you about it. And any more? To the 16. There's a 20 in there also. So that 20, I almost forgot that 20. It's on the written on the other line. So that would be what? 2 times 2 times 5. There we go. Okay, 4 times 5. All right. So when you're figuring out least common multiple, you have to think biggest. And I know that seems like counterintuitive. Least common multiple, you think biggest? Yeah, and let me explain. So the first thing you do is write out all the prime numbers that are in your list. So the primes are 2, 3, 5, and 7. I think those are the only primes, right? And then think biggest. So the biggest power that appears up here for any of them. So for 2, the biggest power is that guy. So that's going to go here. For 3, I believe the biggest power is a 2, which is here. For 5, I think the biggest power is just 1, like this guy. And for 7, same thing. So there you go. And then, of course, you have to multiply all these together. And when you do, it's 5040. So that is the process of figuring out least common multiple. Integers x and y with x greater than y satisfy x plus y is 7 and xy is 12. Integers m and n with m greater than n satisfy m plus n is 13 and m squared plus n squared is 97. If a is x minus y and b is m minus n, determine the value of a minus b. Okay, well, there's that formula. You guys know this one, that a plus b all squared is a squared plus 2ab plus b squared, right? And also a minus b times a plus b is a squared minus b squared. So I'm pretty sure, just based on what they've given us, that you're going to have to utilize these two. And, well, let's see. I'm not entirely sure how, but let me just experiment with this and see what happens. Okay. So first, let's start with the x's and the y's, these guys. So x plus y squared, that's going to be x squared plus 2xy plus y squared, right? Well, x plus y is 7, and xy is 12. So that's going to be 2 times 7. So x squared plus y squared is 49 minus 14, which is what? Sorry, why did I put a 7 there? xy is 12, right? Yeah, so 2 times 12. So 49 minus 24, so 25. Okay. Now at this point, there's only one equation, so I'm pretty sure that we have to solve this with inspection. But it shouldn't be that hard, right? 2 perfect squares that add up to 25. I believe that'd be 4 squared and 3 squared. Yeah, I can't think of any others. And since x is greater than y, that means my x is my 4 and my y is my 3. Okay, so that pretty much takes care of that guy. So in a very similar way, let's figure out the mn stuff. So m plus n all squared, that's going to be m squared plus 2mn plus n squared. So that's going to be 13 squared is, well, m squared plus n squared is 97, and then plus 2mn. So 169 minus 97, that's 72, I believe. Yeah, and then that's 2mn, So mn would be 36. So again, we only have one equation, two variables, so we got to use inspection. And same thing, m is greater than n. So two numbers that multiply to give 36. Well, they're integers, but are they single digit or? That's a good one. Well, they add up to 13. Okay. See, these ones add up to 7, and that's why this is valid, because 4 plus 3 is 7. So two numbers add up to 13 and multiply together to give 36. So 9 and 4. So MIM would be 9 and my n would be 4, because they add up to give 13. Okay, good. And what am I trying to do? This thing here. Okay, so a is x minus y. So that looks to me like 4 minus 3, so a is 1. B is m minus n. So that's 9 minus 4, which I believe is 5. And then finally, they want a minus b. So that looks like 1 minus 5, which is negative 4. So there you go. Robert was born in the year n squared. On his birthday in the year n plus 1 squared, he will be 89 years old. In what year was he born? Okay. So that basically means that on his birthday, so let's just say somebody was born in the year 1900, and they're saying in the year whatever, let's say 1974. Actually, wait, hold on, it would be 1989 actually. In 1989, he'll be 89. So that means 1989 minus 1900 is 89. I'm just trying to put some numbers into it. So that means that the math here would be n plus 1 squared minus n squared is 89. That's the algebra, basically. Okay, so that's it. So I guess just expand this. So n squared plus 2n plus 1 minus n squared is 89. That means 2n plus 1 is 89. 2n is 88. And therefore n is 44. And therefore, in what year was he born? He was born in the year n squared. So n squared is 44 squared. And that is 1936. Suppose that 1 plus a half times 1 plus a third, dot, 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 all the way until 1 plus 1 over k times 1 plus 1 over k plus 1 is 2014. For some positive integer k, what is the value of k? All right, so these guys, well, 1 plus a half is 3 over 2. 1 plus a third is 4 over 3. 1 plus a quarter is 5 over 4. And just kind of keep going like this, dot, dot, dot. And then eventually this is going to be what? K plus 1 over k. And then that one would be k plus 2 over k plus 1, like that. And all this is going to be 2014. So you'll notice that some of these will all cancel. That will cancel with that. That will that. And then that will eventually cancel with something here. That will cancel with the k. This will cancel with that. Everything gets canceled. And the only thing that's left at the end is the k plus 2 and the 2. So that's how you can cancel everything to come up with the answer. So this will be k plus 2 is 4028. So k is 4026. 4026. 4026. Rowena has a very long level backyard. From a particular point, she determines that the angle of elevation to a large tree in her backyard is 15 degrees. She moves 40 meters closer and determines that the new angle of elevation is 30. How tall in meters is the tree? I believe this is going to require some trigonometry. Okay, let's see here. So the tan of 15, let's just say the height is h. So that, let's just call it h. And then from here to here, I'll call that x. So the tan of 15 is h over x plus 40, right? And then the tan of 30, that's going to be h over x. So x tan 30 is h, right? So let's move this up a bit. So the tan of 15 is x times the tan of 30 all over x plus 40. Right? I'm just making basic substitutions. This h, I substituted that one. And then, let's see here. And cross multiply. So we have x tan 15 plus 40 tan 15, which is basically a number. And this is just x tan 15. Sorry, it's x tan 30, sorry. So this 40 tan 15, just keep on one side, and then put everything on that side and factor it out. So it'd be tan 30 minus tan 15. And then you can just solve for x. It'll be 40 tan 15 all over tan of 30 minus tan of 15. Now that's a number, so you can crunch that out. And when you do, let me just see if I did this correctly, tan of 15 times 40, and then tan of 30 minus tan of 15. Yeah, so this number, when you crunch it out, is like 34.64 or whatever. But we don't want x, we want h. But h is this guy. So h is x times tan of 30. And when you do that, you will get a number that is exactly 20, or 19.9999 in your calculator. Line segment PQ has endpoints at P and Q. Point R is a point on PQ, such that the distance from P to R is 1/3 the distance from P to Q. What is B minus A? Let's set this up here. So we've got, let's see here. Let's plot this. P is 6 minus 2, right? So approximately, let's try it, at least try make an attempt to make it somewhat to scale. So that's P, 6 minus 2. And then minus 310. So minus 310. So way up here somewhere probably. Yeah, minus 3 and 10. So that's Q. So let's trying to join these. Okay, that's pretty good. Okay, so now what do they want? They're saying now that there's a point R on this PQ, so that the distance from P to R is 1/3 the distance from P to Q. Okay. All right. So approximately here somewhere. That would be my R, maybe. What is B minus A? Okay, so they got to figure out the coordinates. Okay, so, well, there's several ways of doing this. There's a short way and there's a long way. Of course, we're going to do the short way. So draw that triangle, and if you're going from P to this point right here, you'd be going from 6 to minus 3, right? So that's a distance of 9. Now, this is apparently 1/3. So if we were to drop a line down like that, that's going to be also 1/3. So 1/3 of 9, so we'd be going 3. So that means we'd be going back 3 from 6. So that A, I believe, is a 3. Yeah. Okay, in a very similar way, from this point, which I believe is minus 2, to this point, which is 10, it's a distance of 12, right? So if you drop that, well, it's not drawn to scale, but it's supposed to be a third. And a third of a 12 is 4, so this would be 4. So we'd go from this minus 2 up 4, so it'd be plus 2. So there you go. So A is 3, and B is 2. And what do they want? They want B minus A. So B minus A would be 2 minus 3, which is -1. In how many ways can 105 be expressed as the sum of at least 2 consecutive positive integers? All right, so if you want 2 consecutive positive integers, it'd be x plus 1, right? And they're saying that's 105. Let's see if this works, because we have to get integer values. Well, this would be 2x plus 1 is 105. So 2x is 104, and therefore x is 52. So in this case, the two numbers would be 52 and 53. And so on. And this is a very time-consuming question, and I'm sure you could come up with a faster way by looking at this number 105 and what it can be divided by. That's probably a better a route. What can 105 be divided by? And because our goal is to get integers. And when you do, you'll figure out that it only works when you have 2 consecutive integers, or 3, or 5, 6, 14, 10, and 7, I believe. Yeah. So the 3 would give me 34, 35, 36, and you can do the math. It'd basically be x plus 1 plus x plus 2 is 105, and then you solve for that. And then the 5 would be 19 till 23. Those are 5 integers. The 6 is the 15 to 20. 7 is 12 to 18. 10 is 6 to 15, and 14 is 1 to 14. So there you go. So there's 1, 2, 3, 4, 5, 6, 7 ways. That would be actually the answer that they're looking for. An insect travels from the vertex A to B on the cube shown with the edges of length 1 meter. The insect can travel in exactly one and only of the following ways: crawl along the edges of the cube, crawl along the faces of the cube, or fly through the interior of the cube. What is the shortest time in minutes that the insect can take to get from A to B? Okay, so we got edges, faces, and interior. Edges, faces, and interior. Okay, so let's do it one at a time. Edges. Okay, edges. Okay. Where am I going here? So I guess just edges would be that way, and that way. So I've traveled 3. So I've got to make a little math here. 5 meters per 1 minute. And I've traveled 3 meters by going down those edges, and I have to figure out how many minutes, x minutes. 5 meters for 1 minute, x minutes. Okay. So this is going to be 3 is 5x, so x is 3 over 5 minutes. So x is 0.6 minutes. Okay, that's edges. Now let's do the faces. So faces, what I'm going to do, I'm going to open it up here. Got the top face and the face right below it. So A is here, this corner, and B is here. So if I'm going to go travel through the faces, I'm traveling a straight line like that. Got it? Now I've got to figure out that distance. This is 1, this is 1, this is 1. So by Pythagoras, that distance is 2 squared plus 1 root 5. Yeah? Do you really need me to do it? Okay, I will. What the heck? All right, so AB, that's root 5. That's how I got that. Okay, so then same thing. This time we're going to use this guy. So it's 4 meters for 1 minute, and that's going to be root 5 meters for x minutes. Is that right? Yeah. So that means that x would be root 5 over 4. And in decimals, that is 0.559. Okay. And then finally, we got to do the interior. The interior is basically if we went from A to B like that, well, in a straight line. And that can be figured out by a couple Pythagorean theorems. The first is we got to figure out that base. That's just going to be, this is 1, so that's going to be root 2. And then this is 1, so that's going to be root 2 squared is 2. 2 plus 1 is 3, so that's going to be root 3, I believe. Yes. Root 3, yeah. And you guys can do Pythagoras. It's not a big deal. Okay, so interior. That would be same story. This time is 3 meters per 1 minute. And that's root 3 meters for x. So this x is going to be root 3 over 3. And root 3 over 3 is 0.577. Okay, so now we have to find the shortest. We have to compare. So 0.6, 0.55, and 0.57. So the shortest is the 559. Yeah, this one. So that is the answer to the question. There you go. In an arithmetic sequence with 20 terms, the sum of the first 3 terms is 15. The sum of the last 3 terms is 20. What is the sum of the 20 terms in the sequence? So the terms are a plus d, a plus 2d, and so on, right? You guys get the point. All the way up until a plus 19d would be the last term. And they tell me the first 3 terms, so a plus d plus a plus 2d, that would equal 15, correct? Okay, so that's 3a plus 3d is 15. So that means a plus d is 5. And then the last 3 terms is 12, the sum. So the last 3 terms would be a plus 19d, a plus 18d, and a plus 17d. And that is 12. So this looks like 3a plus 54d, I believe. And that's 12. And then I can divide through by 3 to get a plus 18d is 4. Okay, we got 2 equations, 2 variables. Shouldn't be a problem. Let's subtract these 2. And when we do, we get 17d is equal to minus 1. So d is negative 1 over 17. And then we have to add up all, they want the sum of all the 20 terms. Okay, so all the 20 terms, that would be a plus d plus a plus 2d plus, and you guys get the point, all the way to a plus 19d. Okay, first let me figure out a with this equation by substituting this guy. And when I do, I get a is equal to 5 plus 1 over 17. I'll just leave it at that for now. Okay, so this guy, that's going to be 20a. And then I'm going to be adding 1 plus 2 all the way till 19. Using that formula, that's 19 times 20 over 2d. So this is 20a plus 190d. Okay, now we're almost done. 20a is 5 plus 1 over 17. And d is a negative 1 over 17. And therefore we have 100 plus 20 over 17 plus, minus 190 over 17. And then that's going to be minus 170 over 17. So that's going to be 100 minus 10, which is 90. Oh, nice. 90 is the answer. A parabola has equation y is equal to k squared minus x squared for some positive integer k. Remember, rectangle ABCD is drawn with sides parallel to the x-axis or axes, so that A and D are the points where the parabola intersects the x-axis, so that the vertex V of the parabola is the midpoint of BC. If the perimeter of the rectangle is 48, what is the value of k? Let's label this first. So we have y is equal to k squared minus x squared. When x is 0, y will be k squared. So that means V has the coordinates 0, k squared, I believe. And then when y is 0, you'll have k squared minus x squared. So k squared will be x squared. So x will be either plus or minus k. So that means d will be k0, like that, and A will be minus K0 like that. So they're saying this rectangle is 48, and what is that rectangle? I'm assuming the one, this rectangle? Okay. So this from here to here is K, that's also K, and then this is also K, and that's K, and this top to bottom is K squared on both sides. So if you add up all that, it's 4K plus 2K squared, and that is 48. Okay, so I'm assuming that's all there is to this question. Put everything on one side, divide through as much as we can. We get 2, let's see here, K squared, if I divide through by 2, plus 2K minus 24. And I think this factors K, 6 and 4, and then positive, negative. So K is 4 or negative 6, but K has to be positive. Well, because they told me it's positive, so that means K is 4. A graph is a diagram consisting of points and line segments joining some pairs of points, starting with the original graph with 5 vertices as shown below. 5 new graphs are formed by removing one of the vertices from the original graph and all the edges joined to this vertex. This process is repeated starting with an original graph with 10 vertices. How many edges did the second original graph have? Okay, so not a very scientific way, but what you do is you superimpose the first two. So you take this guy and this guy and put them on top of each other, and when you do, you should be able to get all the vertices and edges of the original graph. So when you do, let's put that superimposed image here, and that is what it is. And let's count the vertices and edges as best as I can. So vertices 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 vertices. And then now the edges 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So 14 edges, which is the answer to that question right there. A quantity of gray paint has a mass of 12 kg. The gray paint is a mixture of black paint and white paint, of which 80% by mass is white paint. More white paint is added until the mixture is 90% white paint by mass. What is the total mass of the paint resulting? So we start off with 12 kg, and 80% of that is white paint. So 80% of 12, I believe, is 9.6 kg. And the remaining 20% is the black paint, and that is 2.4 kg. Okay, so at this point, they're saying they're going to add some additional paint to make the percentage of white paint increase to 90. Now, I don't know how much that is, but it's X, let's say. So that means now that 9.6 plus X over the total, which would be 12 plus X, that's going to be 90. So this is my new white paint mass, and this is the new total mass. And I guess total mass is the new total mass is what they're asking. So eventually I'm going to have to figure out what is 12 plus X, but first I have to figure out X. So from that equation, let's cross multiply. We get 9.6 plus X would be 10.8 plus 0.09x, and therefore this would be 0.1x, and this would be 1.2, so x would be 12, and therefore the 12 plus x is 12 plus 12, which is 24 kg, is the new total mass. In a regular polygon, a diagonal is a line segment joining a vertex to any non-neighboring vertex. For example, a regular hexagon has 9 diagonals. If a regular polygon with n sides has 90 diagonals, what is the value of n? Well, let's start off with a hexagon, and let me try to explain this. So here's six sides and 6 vertices, right? So when we draw a diagonal, let's start from here. Let's call that A. Diagonal is a line segment joining a vertex to any non-neighboring vertex. So not to here and not to here. So a non-neighboring vertex would be that guy or this guy or this guy. So as you can see, I was able to draw 3. But what if you had many, this has 6 sides, but what if you had 25 sides, right? How many lines would I draw? Well, it's very simple. The number of lines or diagonals would basically be equal to the number of vertices minus 3. Now you say, well, why minus 3? Because this is the original vertice, and then you cannot draw a diagonal to its 2 neighbors. So those 3 is why it's minus 3. But you can draw a diagonal to any of the others. So for example, for this one, the number of vertices total was 6, right? So the number of diagonals would be 6 minus 3, which is 3, which is exactly the number of diagonals I just drew. So in general, if you have n vertices, the number of diagonals would be n minus 3, right? So that's exactly what I wrote. So how many total diagonals? Well, for each vertice, the number of diagonals, d, is n minus 3, right? But there's a total of n vertices. So the total number of diagonals would be n times n minus 3. Okay? That's the total number of diagonals. And they're saying they want that number to be 90. So essentially what they're saying, let me just think about this for a second. If it's actually n times n minus 3, I think you have to divide by 2. Because otherwise we would have double counted. Because eventually if you get here and you draw a diagonal, it's going to be the same diagonal that I already drew. So I'm pretty sure this is correct. Yeah. Gotta be careful there. Okay, so they want this to be equal to 90. Okay, so that is what I need to do. I need to set this n times n minus 3 over 2 equal to 90, and then just solve that algebra there. All right, so that means n squared minus 3n is 180. So n squared minus 3n minus 180 is 0. Let's see, does this factor? N 15 and 12, I believe, and then be minus plus. So n would be 15. That's because obviously we need n to be a positive number. Determine the number of triples ABC of 3 positive integers with a less than b less than c, whose sum is 100 and whose product is 18018. Okay, so we want the 3 numbers to be 18018, and we want the sum is a plus b plus c, and that's 100. Okay, so this ABC, this 18018, I want to break it up into prime factors. So it'd be 2 times 3 squared times 7 times 11 times 13. Okay, so so I think perhaps we can set this up so that A is some, A is less than B less than C. So let's make A some multiple of 7, B some multiple of 11, and C some multiple of 13. And then that would mean that ABC would be 7k times 11m times 13n. So that would be, let's see here, 7 times 11 times 13 times this k times m times n. But this ABC is this guy right here, which is 2 times 3 squared times 7 times 11 times 13. And that's going to equal 7 times 11 times 13 times k times m times n. So that means that 2 times 3 squared is this k times m times n. And that means that would be 18. And I think because this is important, we got to make sure that ABC adds up to 100. So we have kind of narrowed it down to some limited options, and that helps us. So let's now, using that fact, this fact, and this fact, and these guys, let's make a table. So here we go. Here's the big long table, and we've got all the facts. We've got the fact that a plus b plus c has got to eventually equal 100. A times b times c is that guy. And we have let a be a multiple of 7, b be a multiple of 11, and c be a multiple of 13, such that those multiples add up to 18. So here we go. So that makes our KMN kind of limited as to what we can. It's still a pretty long list, but then we eventually can plug in to these guys to get our values for a, b, and c, and then we can add up a, b, and c and see if any of them equal 100. So it's still a bit time consuming, but that's the only kind of way we can narrow things down. So when you do all this, the only time a plus b plus c is equal to 100 is those two. And it's these triples, but you got to make sure when you write them that a has got to be less than b has got to be less than c. So you got to write the triples in that way. So the ABC triples that would work would be 11, 26, 63, or 13, 21, and 66. We define AB symbol CD to be AC minus BD, or AD plus BC. Determine all pairs XY for which X3 symbol XY is 6, 0. All right, so just use this definition here to figure this guy out. So that's going to be x squared minus 3y, xy plus 3x, I believe. And that is 6, 0. Okay, so that means that x squared minus 3y is 6, and xy plus 3x is 0. So if I factor out x here, I get y plus 3 is 0. So that means either x is 0 or y is negative 3. Yeah. Okay, so if x is 0, that put into there makes this minus 3y is 6, so y is minus 2. So my first pair is 0, negative 2. And then now this guy, if y is minus 3, if I put that in there, it'll be x squared minus 3 times minus 3 is 6. So x squared is equal to 6 minus 9. So x squared would be negative 3, which is not possible, right? Because it doesn't say anything about the nature of x and y. Yeah, it doesn't say if they're integers, but I'm assuming they are. Interesting. Because, I mean, it could be imaginary, but they don't say anything about that. So I guess this is the only solution to what they want. A standard die is a cube whose faces are labeled 1 through 6. Raffi rolls a standard die 3 times, obtaining the results P, Q, and R on the first, second, and third rolls, respectively. What is the probability that P is less than Q is less than R? So, in any probability question, it's usually a fraction, and the top is the specific condition, which they have explained in the question, and the bottom is the total. So if you roll 3 die, the total would be the total number of outcomes, I guess, The first die has 6 outcomes. The second die also has 6, and the third die also has 6. So the bottom would be 216, I believe. Now the top, that's a specific condition. That one we need to talk about. Okay, so then, all right, so what am I trying to figure this out now? How do I do this? Well, you got 6 numbers, right? 1 through 6. And from those 6 numbers, we have to choose 3 numbers. 1 for P, 1 for Q, and 1 for R. So 6 choose 3. And 6 choose 3 is 20. And then once you get those 3 numbers, we want them to be in that order. So for example, if the 3 numbers I chose were 2, 3, and 6, I want the 2 to be the P, and I want the 3 to be the Q, and I want the 6 to be the R, so that P is indeed less than Q less than R. So once we choose the 3 numbers, there's only one way to assign them to make that inequality true. So this 20, each of those 20 has only one way of being assigned. So that means the specific condition is only 20. I'm pretty sure that's right. So then that would be 20 over 216, and then this in lowest terms, 5 over 54, I guess. Yeah. Determine the largest possible radius of a circle that is tangent to both the x-axis and y-axis and passes through 9, 2. Let's draw this. So we've got x-axis, y-axis, and then, okay, it's tangent, right? Tangent to both axes. So let me draw that. Okay, so there's a circle I've drawn, and I've got to make sure that 9, 2 is on the circle. So that's the tangent points. That's the center point. And then 9, 2, so approximately, I don't know, here maybe. So that's 9, 2. So that's 9 and that's 2, approximately. Okay, so what are we trying to do in this question? Determine the largest possible radius. Okay. So here's the radius, R. Here's the radius, R. And there's the radius, R. And therefore the center is RR. Okay. And then according to the formula for a circle, it's x minus, it would be x minus r squared plus y minus r squared is equal to r squared, based on everything in the question. So we also know that 9, 2 is on the circle, so I can sub 9, 2 into there. So 9 minus r squared plus 2 minus r squared is r squared. And then, of course, I got to expand this out. So 81 minus 18r plus r squared plus 4 minus 4r plus r squared is r squared. Let's put everything on one side. And when I do, I get r squared minus 22r plus 85 is 0. I think this might factor. Let's try r 17, 5 minus minus. There we go. So r is either 5 or 17. And, oh, they want the largest possible. Okay, so the largest is 17. So there you go. For each positive integer n, define s at n to be the sum of the digits of n. For example, s at 2, 0, 1, 4 is 2 plus 0 plus 1 plus 4, which is 7. Determine all positive integers n with n between 1,000 and 999 inclusive, for which n divided by s at n is 1/12. Let's say that number is of the form a, b, c, d. Yeah, because if it's in that range, it's always going to have 4 digits, right? Yeah. And therefore, n is going to be 1000A plus 100B plus 10C plus D. And then S at n, which is the sum of the digits, would be just A plus B plus C plus D, like that. So this formula here, n over S at n, would be 1000A plus 100B plus 10C plus D all over A plus B plus C plus D, like that. And we want that to be 112. Okay, so let's do this math. So 1000A plus 100B plus 10C plus D, and that's going to be all 112A, 112B, 112C, and 112D. Okay, so let's, and then now we have to do something, a little bit of fancy algebra. Not extremely fancy, but we got to figure out how best to deal with this problem. So let's keep the A's on one, A and D on one side, and the B and C on the other. So when I do that, I get 8, 8, 8A minus 1, 1, 1D, and this side becomes 12B plus 102C. And then I divide through by 3, I believe. So I get 296A minus 37D is 4B plus 34C. And, okay, so I think I can factor out a 37, and when I do, I get 8A minus D is equal to 4B plus 34C. Okay, so that means this side is divisible by 37, obviously. So that means this side has to be divisible by 37. So it has to be a multiple of 37. And also, if you can, you notice you can factor out a 2, so it's also even. That side is also even. Okay, so we use those 2 points to now, since we have just one equation and 4 variables, the only way to solve this is with these 2 pieces of information. Okay, so let's try multiples of 37 for 4B plus 34C. Let's try the first multiple, which is 37 times 0. When you do that, we get B equal to 0, C equal to 0. And then when we plug that into here, we would get 8A plus minus D is equal to 0. And the only, is it integers? Yeah, it's integers, right? Because these are all positive integers. Well, they're all digits. The way I wrote it, A, B, C, D are digits for a integer. So obviously A, B, C, D are integers. Single digit integers, actually. And the only single digit integer solution for this would be A equal to 1 and D equal to 8. So that means my A, B, C, D, in this case, would be 1, 0, 0, 8. So there we go. We got 1 so far. Okay, so hopefully that's not too painful. Let's try the next multiple of 37. 37 times 2. But it's got to be an even multiple of 37. Yeah, and 0 is an even number, by the way, just in case you're wondering. I'll save some time and tell you that there's no values for which this works, no integer values. 4B plus 34C is equal to 37 times 4, the next one. This one gives me B equal 3, C equals 4. And then when I solve for A and D using this part of the equation, I would get A equal to 1 and D equal to 4. So my A, B, C, D in this one is 1, 3, 4, 4. Okay, so hopefully you're getting the hang of this. Next one is 4B plus 34C is equal to 37 times 6. And that one, you guys, I'll save you the trouble. There's no values for which we get integer solutions. And then next one, 4B plus 34C is 37 times 8. That one gives B equal to 6 and C equal to 8. And then for A, we actually get two solutions. We get A equal to 1 or A equal to 2. And this one will give D equals 0. This one will give D equals 8. So these ones will give me 1680 or 2688. So those are your numbers. So this one, 1008, 1344, 1680, or 2688. In the diagram, cube has edges length A. Points M, N, and P are on edges GC, FB, and EA respectively, so that MC is half of A, NB is a third of A, PA is a quarter of A. If the plane defined by points M, N, and P intersect HD at T, determine the length DT. Okay, so we have to draw a little diagram. And I just put that diagram right beside the original one to kind of illustrate what they want. They eventually want us to figure out the length of DT. Now, D is shown in the original diagram. It's hidden in the second one, but you guys understand the distance from D, which would be sort of at the bottom all the way up to T. Okay, so how do we do that? Well, X, if you can see in this diagram over here, is the midpoint of PM. It's also the midpoint of TN, those two diagonals. So write that in there. X is the midpoint of PM, and it's also the midpoint of TN. So let's figure this out. So if X is the midpoint of PM, X would be equal to MC plus PA divided by 2. And therefore that's going to be A over 2 plus A over 4 divided by 2. And that is 3A over 8. Got it? And in a very similar way, since X is the midpoint of TN, it would be equal to TD plus NB all over 2. So that's going to be TD plus A over 3 all over 2. And X we just figured out was 3A over 8. So let's put that in there, 3A over 8. And then I guess I can solve this. Will it be in terms of A? If the plane is to determine the length of... Yeah, because I don't see the value for A. Yeah, it's got to be in terms of A because we don't know the value of A. Okay, so let's figure this out. So what am I going to do here? So let me just see. The 3A over 4 will be TD plus A over 3. And then TD would be 3A over 4 minus A over 3. Hold on, did I do this right here? Yeah. Okay. So common denominator, 3, 3, 4, 4. 9A minus 4A over 12. So TD is 5A over 12. Yeah, so I did get an answer in terms of A, and although they don't really say determine the length of DT in terms of A, but since A does not have any value, that's the only thing I could provide. In trapezoid ABCD, AD is parallel to BC and BC to AD is 5 to 7. Points F lies on AD and point E lies on DC, so that AF to FD is 4, 3 and CE to ED is 2, 3. If the area of the quadrilateral ABEF is 1, 2, 3, determine the area of trapezoid ABCD. Okay, so the first thing I'm going to do is draw a line, sort of drop it from D down to the bottom there, and then connect that like that. So what's the purpose of that? Well, the purpose of that would be to use, and then I'm going to draw another one sort of connecting those two guys. This dot to that line that I just drew like that. Okay, so the purpose of that actually is to use the fact that these ratios that they've given us, which is DE, this CE to ED is 2 to 3. So that means from here to here and from here to here will be 3 to 2, right? DE to CE. Okay, so let me just call it 3H and 2H. So H is height. And then similarly, AFD is 4 to 3, so I'll just call it 4x and 3x. And therefore that whole thing is 7x. And then any other BC and AD is 5 to 7. Well, since that was 7x, this will just be 5x. Okay, I think that's pretty good. Okay, so what is it? What are we trying to do here? ADBC is the same as ABCD, right? Okay, let's not make this complicated here. ABCD, that trapezoid. How do you figure out the area of a trapezoid? You take the top and the bottom, and then you add them. So in this case, it would be 5x plus 7x divided by 2, and then multiply by the height, right? So in this case, my total height is this plus that, so it's 5h. So this looks like 12x over 2 times 5h, so that's 6, or rather, yeah, 6 times 5, so 30xh. Okay, that's good, I guess. Now let's proceed with what else can I do here? I've got some triangles that they've given me, or have they? Well, they gave me ABEF for some reason. ABEF. So let me draw that in. ABEF. ABEF. So right there like that. So that guy is 123. Okay. So then I've got these other two triangles. I've got a triangle FDE to worry about and triangle BCE. Okay, well this guy is 1/2 base times height. The base I can use 3x and the height I can use 3h. So that's going to be 9 over 2xh. BCE, the base I can use 5x and the height I can use 2h. So that's going to be 5xh. Correct? So now ABCD is the total. So it's that 123 plus that 9 over 2xh plus that 5xh. And yeah, and that is 30xh. So perhaps this will lead to something. Yeah. Okay. What do I do here? 123, I guess I collect like terms. So this is 30xh minus, what is that? 4.9.5xh. So that's 20.5xh is 123. So xh is 6. And then what are we trying to figure out in this question? Determine the area of trapezoid ABCD. So ABCD was 30xh. ABCD. And then, okay, I got what xh is. So then that's 30. Okay, I got it. So it's 180 is the answer to this question.